From space, our planet does not look like Earth. It looks like an ocean world, blue, vast, endless. Oceans cover more than 70% of Earth's surface. Yet when we speak of Earth, we usually mean the land, continents, mountains, forests, cities. But the truth is that land is the exception. Water is the rule, and within those waters lies a world we barely understand. For all our technology, our satellites, our exploration of the Moon and Mars, we have explored less than 5% of Earth's oceans. The rest is uncharted, unknown, waiting in silence. The irony is staggering. We know more about the surface of Mars than the floor of our own seas. We have mapped galaxies, but vast stretches of Earth's ocean remain a blank space on the map. The ocean seems familiar because it is part of our lives. We swim in it, fish from it, sail across it. Coastal waters and shallow seas give the illusion of knowledge. Coral reefs, dolphins, whales. We think we know the ocean because we see its surface, but the ocean's layered. And beyond the shallow sunlit zone, everything changes. Light fades, pressure builds, temperatures drop. Entire ecosystems thrive in darkness, with creatures so alien they might as well be from another world. The deeper we go, the stranger it becomes. For centuries, the ocean was a realm of mystery and terror. Ancient sailors told stories of kraken, giant tentacled beasts that could drag ships beneath the waves. Greek myths spoke of Charybdis, a monstrous whirlpool that swallowed sailors whole, and Scylla, a sea demon with snapping jaws. Even into the age of exploration, the ocean was drawn on maps with sea serpents and warnings. Here be monsters. In a way, the myths were not wrong. The ocean does hold monsters, though not always the ones imagined. Colossal squid, 40-foot long, lurk in the depths. Sharks larger than buses patrol the seas, and microbes, invisible yet ancient, form the foundation of ocean life. The ocean has always been both promise and threat, the source of food and travel, but also storms, shipwrecks, and unfathomable depths. For most of history, humans could barely scratch the ocean's surface. Free divers plunged to limited depths. Wooden ships sailed above vast trenches they could not imagine. Even today, modern submarines can only explore fragments of the deep. The deepest point ever reached by humans is the Challenger Deep in the Mariana Trench, almost 7 miles down. Fewer than a dozen people have ever been there. Fewer than have walked on the moon. Meanwhile, the deep sea stretches across the globe. The trenches alone account for tens of thousands of miles, and most have never been seen. Our ignorance is not for lack of trying. It is because the ocean is one of the most hostile environments on Earth. Pressure increases by 1 atmosphere every 10 meters. At the bottom of the Mariana Trench, pressures exceed 1,000 times that at sea level, enough to crush submarines like soda cans. Sunlight vanishes within 200 meters, leaving the majority of the ocean in perpetual night. Temperatures plunge near freezing, and strange chemistries dominate. Life here must adapt in ways that defy imagination, glowing with bioluminescence, feeding on chemicals from volcanic vents, surviving on scraps that fall like marine snow from above. The ocean is not just unexplored, it is unexplorable by ordinary means. Every dive is a battle against crushing pressure, freezing darkness, and unknown terrain. When people speak of exploration, they often point to space as humanity's final frontier. But in truth, the greatest frontier is still here, on our own planet. The ocean is our inner space, a mirror to the cosmos. It is vast, hostile, and alien. It is filled with unknown life, unexplored landscapes, and unanswered questions. Every expedition returns with discoveries, new species, strange geologies, bizarre phenomena, and every discovery reminds us that we know almost nothing. The ocean holds secrets that may change our understanding of life, of Earth, perhaps even of ourselves. How deep have we really explored the ocean? What lies beyond the limits of light, beyond the reach of submarines, beyond the edge of maps? Do monstrous creatures roam the abyss? Do vast ecosystems exist, unseen by human eyes? Could lost cities or even entire worlds of life wait below? The ocean is both a scientific frontier and a place of wonder and fear. Every question we ask about it is tinged with possibility and with dread. In this journey, we will descend layer by layer. We will move from the familiar sunlit surface to the twilight zone, to the midnight abyss, to the Hadal trenches. Along the way, we will confront myths, legends, anomalies, and realities stranger than fiction. We will ask, what have we discovered? What remains hidden? And why does the ocean matter to the future of our planet? This is not just a story of fish and water. It is a story of life, death, survival, and mystery. A story of a world that is both our cradle and our last unknown frontier. The ocean waits. The question is not whether it hides mysteries. The question is, how much of its truth are we prepared to face? The uppermost layer of the ocean, where sunlight penetrates, is called the epipelagic zone, or more simply, the sunlit zone. It extends down only about 200 meters, just 656 feet. Beyond this, sunlight fades and the ocean shifts into twilight. It is in this thin layer of light that most marine life familiar to humans resides. Coral reefs blaze with color. Schools of fish shimmer like liquid silver. Whales breach the surface. Dolphins play in the waves. For many people, this is the ocean. Beaches, coastal shallows, tropical reefs. But in truth, This zone is only the thinner skin of a vast layered ocean world. Because humans spend so much time in or near the sunlit zone, we imagine we understand the ocean. We dive here, swim here, fish here. We map shipping routes across its surface and launch satellites to track its waves. But this is an illusion. The sunlit zone makes up less than 5% of the ocean's volume. Everything below, 95% of the ocean, is invisible, uncharted, and largely unknown. In a way, our relationship with the ocean is like judging the earth by its clouds. We see the surface, but the true reality lies beneath. Among the wonders of the sunlit zone are coral reefs, vast structures built by tiny coral polyps. These reefs are among the most biodiverse ecosystems on Earth, rivaling rainforests. A single reef can host tens of thousands of species: fish, crustaceans, mollusks, sponges, and more. To early sailors, coral reefs were both paradise and peril. They provided food and beauty, but they also wrecked ships on their shallow, hidden barriers. Legends arose of reefs as haunted places, filled with spirits or guarded by gods. Today, we know coral reefs as fragile ecosystems under threat from warming seas, acidification, and pollution. Their decline is a warning. Even the ocean we think we know is more vulnerable than we realize. The sunlit zone is also home to Earth's largest creatures, whales. Blue whales, the largest animals ever to live, cruise through these waters, feeding on tiny krill. Their songs travel hundreds of miles, a form of communication we are only beginning to decode. For centuries, sailors feared whales as sea monsters, mistaking their blows for geysers or their backs for islands. The biblical story of Jonah and the whale reflects this awe and fear. Yet whales are not monsters, but intelligent beings with complex societies. Their presence in the sunlit zone is a reminder that we share this thin skin of ocean with creatures both ancient and extraordinary. Because humans spent most of history in small boats, close to the surface, many of the earliest myths of the sea came from this zone. Sailors told of sirens, beautiful creatures luring men to their deaths. They spoke of sea serpents, glimpsed in the rolling waves, perhaps giant eels or oarfish breaking the surface. Even natural events became myth. Whirlpools were imagined as gateways to the underworld. Sudden storms were seen as punishment from gods. The surface ocean is dynamic, shifting, and deceptive. To those who depended on it, it seemed alive, filled with both beauty and danger. For humanity, the sunlit zone has always been a source of sustenance. Coastal waters provide the majority of the world's fish catch. Ancient civilizations rose near seas and rivers because of the food they offered. Even today, Billions of people depend on fish as a primary source of protein. Shipping routes, global trade, and economies all flow across the sunlit seas. We imagine this resource is infinite, but it is not. Overfishing has decimated populations, from cod in the Atlantic to tuna in the Pacific. The very zones we think we know are slipping beyond balance. The sunlit zone is also critical to Earth's climate. Phytoplankton, microscopic plants that float near the surface, absorb carbon dioxide and release oxygen. In fact, phytoplankton produce more than half of Earth's oxygen. Every other breath you take comes from the ocean, and yet most people have never seen them. These tiny organisms, invisible to the naked eye, sustain the atmosphere. The surface ocean is not just water. It is a machine of climate, a regulator of life, a fragile system upon which the entire planet depends. The sunlit zone may seem vast, but it is only a doorway. Beneath its brightness lies the twilight, the midnight, the abyss. The majority of the ocean, billions of cubic miles, exists in darkness. Creatures live there that have never seen sunlight and perhaps never will. Our sense of familiarity blinds us to the truth. We know almost nothing. We fly over oceans, sail across them, even peer into them with satellites. But this mastery is skin deep. We control the surface, not the depths. We chart the coasts, not the trenches. The ocean remains wild, alien, and unyielding. The sunlit zone is a friendly mask over a realm that is anything but. As we leave the sunlit zone behind, we enter the mesopelagic zone, the twilight ocean. Here, light fades to shadow. Creatures glow with bioluminescence. Pressure builds. It is a place of alien life and strange adaptation, where myths of sea monsters begin to brush against reality. In the next chapter, we descend into this twilight world, a place both haunting and beautiful, where the ocean begins to reveal just how little we know. At about 200 meters below the surface, sunlight begins to die. Colors vanish. Reds and yellows disappear first, leaving only faint blue and green. By 1,000 meters, almost no sunlight remains. This is the mesopelagic zone, known as the twilight zone. It is here that the ocean transforms. The vibrant reefs and glittering surface life fade into dimness. Pressure builds. The water grows colder, and creatures evolve in ways that defy imagination. Though hidden from view, the twilight zone is vast. It may contain more biomass, more sheer living matter than all the fish in the surface ocean combined. Yet it is among the least explored habitats on Earth. In the absence of sunlight, life makes its own. The twilight zone is ruled by bioluminescence, the ability of organisms to glow with their own light. Jellyfish pulse with neon blue. Lanternfish carry glowing spots along their bodies. Squid flash patterns of green, blue, and red. Even microscopic plankton burst into sparks when disturbed, creating waves of glowing water known as sea sparkle. Bioluminescence serves many purposes: camouflage, communication, mating, and hunting. Some creatures use it to lure prey, others to confuse predators at dawn. Some even create searchlights to see in the dark. In a world without sun, light becomes currency, weapon, and survival strategy. Every night, an invisible migration takes place. Billions of creatures from the twilight zone rise toward the surface to feed under the cover of darkness, then return to the depths by day. This is the largest migration on Earth, larger than the movement of wildebeest or monarch butterflies. It happens every single night, in every ocean, and yet it was not discovered until the 20th century. The creatures making this journey include lanternfish, shrimp, squid, and countless others. They form a living conveyor belt, transferring nutrients between the surface and the deep. Without them, the balance of the ocean, and perhaps the planet, would collapse. The twilight zone has long been a source of myth. Sailors glimpse giant, glowing shapes rising from the depths. Perhaps squid, perhaps whales, surrounded by bioluminescent plankton. To them, these were monsters of the deep. Stories of sea serpents may have come from oarfish, long silver creatures that can reach 30 feet, rarely seen except when dying near the surface. Tales of glowing ghost ships may have been the result of bioluminescent plankton swirling around hulls. In this way, the twilight zone blurred the line between reality and myth. The creatures were real, but so alien that they seemed supernatural. In the twilight zone, life must adapt to extremes. Food is scarce. Pressure is immense. Predators are everywhere. Some fish, like the barreleye, have transparent heads and tubular eyes that can rotate upward to spot prey silhouetted against faint light. Others, like the dragonfish, have invisible red bioluminescence, allowing them to see without being seen. Many creatures are small, delicate, gelatinous. Others, like squid and siphonophores, grow to astonishing lengths. Some siphonophores, colonies of specialized organisms working together, can stretch more than 150 feet, longer than a blue whale. These are not creatures of myth. They are real, and they remind us how little we know of life's possibilities. The twilight zone may play a crucial role in Earth's climate. Creatures migrating daily between surface and deep transport carbon, locking it away in the depths. This process, sometimes called the biological pump, may regulate Earth's atmosphere. If disrupted by overfishing or climate change, the consequences could be global. Yet because the twilight zone is so poorly studied, we don't fully understand its role. It is a silent guardian of balance, hidden in darkness. Exploring the twilight zone is difficult. Submarines can visit, but the sheer size of the region makes systematic study impossible. Nets often damage fragile creatures before they can be examined. Cameras reveal glimpses, but the deep scattering layer, dense with migrating animals, remains elusive. New technologies, like autonomous robots and submersibles, are beginning to map this realm. Yet even with modern tools, the twilight zone resists exploration. It is too vast, too fragile, too alien. Every dive returns with surprises, creatures never before seen, behaviors never before imagined. For every answer, 10 questions emerge. Some scientists estimate that 90% of twilight zone species are unknown to science. That means we have catalogued only the tiniest fraction of life in this vast, shadowy world. What kinds of creatures wait unseen? Could there be giants beyond imagination, or life forms with chemistries utterly unlike anything we know? The ocean has a way of humbling us. Every time we think we understand, it reveals more. The twilight zone is perhaps the greatest reminder of this humility. As light vanishes completely, the twilight zone gives way to the midnight zone, the bathypelagic depths where darkness is absolute, pressure is crushing, and life takes on even stranger forms. If the twilight zone is a realm of shadows, the midnight zone is a realm of night eternal. And within it dwell creatures that seem to come straight from nightmares. In the next chapter, we plunge into that abyss. At about 1,000 meters down, sunlight vanishes entirely. This is the bathypelagic zone, the midnight zone. It stretches to 4,000 meters, followed by the abyssal zone, which continues to 6,000 meters. Here, there is no dawn, no dusk, no stars. The ocean is pitch black, silent except for the groans of shifting water. Temperatures hover just above freezing. Pressure crushes at hundreds of atmospheres. To human eyes, this is a void. But to the creatures that live here, it is home. Despite the crushing conditions, the midnight zone teems with life. But these creatures are like nothing found in shallower seas. The anglerfish dangles a glowing lure from its head, attracting prey into its gaping jaws filled with needle-like teeth. The fang-toothed fish has the largest teeth in proportion to body size of any fish on Earth. The gulper eel can expand its enormous mouth to swallow prey nearly its own size. Many creatures are transparent, gelatinous, or grotesque in ways that seem designed for nightmares. They are not monsters. They are survival embodied, adapted perfectly to a world of darkness and scarcity. Among the most legendary inhabitants of the midnight zone are the giant squid. Once thought to be myth, these elusive creatures can reach lengths of 40 feet or more. Their eyes, the size of dinner plates, are the largest in the animal kingdom, perfect for spotting faint glows in the abyss. For centuries, sailors told stories of the kraken, a monstrous squid that could sink ships. While no squid has ever attacked a vessel, the reality is almost as astonishing. Battles between giant squid and sperm whales scar the deep, leaving whales covered in sucker marks as proof of their titanic struggles. The giant squid remained unseen by humans until 2004, when Japanese researchers captured the first images. To this day, sightings are rare, reminding us how much of the deep remains out of reach. The midnight zone is not just dark, it is deadly. Pressure increases by 1 atmosphere every 10 meters. At 4,000 meters, pressures reach 400 atmospheres, or 5,800 pounds per square inch. For perspective, that's equivalent to having 50 jumbo jets pressing down on your body. Yet life thrives here. Creatures survive not by resisting pressure, but by adapting to it. Their bodies contain few air pockets. Their proteins and cell membranes are built to function in crushing conditions. To them, the abyss is not extreme, it is normal. Beneath the midnight waters stretch the abyssal plains, vast, flat expanses covering more than half the ocean floor. These plains, lying between 4,000 and 6,000 meters deep, are among the flattest, most featureless places on Earth. But they are not lifeless. Strange starfish, sea cucumbers, and brittle stars creep across the sediment. Ghostly fish drift above. The abyssal plains are littered with marine snow, a slow rain of organic matter from the surface that sustains life below. Occasionally, whale carcasses sink to the depths, becoming whale falls that feed ecosystems for decades. In the abyss, death above gives life below. Not all life in the abyss depends on scraps from above. In 1977, scientists discovered hydrothermal vents, fissures in the seafloor where superheated water gushes from Earth's crust. Around these vents thrive ecosystems unlike any other. Tube worms more than 6 feet long cluster around chimneys of minerals. Clams and crabs feed on bacteria that survive not on sunlight, but on chemosynthesis, the ability to draw energy from chemicals like hydrogen sulfide. These vents overturned our understanding of life. No longer was sunlight the only energy source. In the abyss, life writes its own rules. Some scientists now believe life on Earth may have begun at vents like these, and that similar environments may exist on icy moons like Europa or Enceladus. The most dramatic vents are called black smokers, spewing water heated to more than 400 degrees Celsius. Though the water is superheated, it does not boil because of the immense pressure. Minerals crystallize into towering chimneys, some more than 200 feet tall. Around them, ecosystems flourish in a world that should be sterile. Shrimp swarm in boiling currents. Bacteria form mats that glow faintly. In these oases, life thrives against all odds. The black smokers are reminders that the abyss is not barren, but fertile in ways we are only beginning to understand. Exploring the midnight zone is an enormous challenge. Few submersibles can withstand the pressures. Remotely operated vehicles, ROVs, capture footage, but each dive covers only tiny patches of the vast abyss. The Challenger Deep, the ocean's deepest point, has been visited fewer than a dozen times by humans. By comparison, more than 600 people have been to space, and 12 have walked on the moon. We have mapped other planets more thoroughly than the abyssal plains. The deep ocean remains, in many ways, a frontier as unexplored as space. The midnight ocean exerts a psychological pull. It is at once terrifying and magnetic. To stare into footage from the abyss is to confront a world that feels alien, yet is part of our own planet. It is a mirror of our fears, darkness, pressure, creatures of nightmare. And yet, it is also a mirror of possibility, life finding a way where none should exist, ecosystems thriving in the most extreme conditions. The abyss forces us to ask, if life can survive here, where else might it exist? Beyond the abyssal plains, the sea floor plunges deeper still. Trenches slice into the crust, descending more than 11,000 meters. These are the Hadal zones, the ocean's deepest scars, where pressures reach the limits of imagination. In the next chapter, we will descend into these trenches, into places visited fewer times than the moon, where alien microbes thrive in rock and sediment, and where mysteries still wait in silence. Beneath the abyssal plains lies the most extreme region of the ocean, the Hadal zone. Named after Hades, the Greek underworld, it begins at 6,000 meters, 20,000 feet, and plunges to nearly 11,000 meters in the deepest trenches. This is a world of isolation. Trenches cut into the seafloor like scars, formed where tectonic plates collide and one dives beneath the other. They are narrow, steep-sided, and unimaginably deep. The most famous is the Mariana Trench, home to the Challenger Deep, nearly 11 kilometers below the surface. To stand at sea level and look up at Mount Everest is to glimpse its scale. Now flip that mountain upside down, submerge it, and you have the depth of the Mariana Trench. It is the most extreme place on Earth and one of the least explored. At the bottom of the Challenger Deep, pressures exceed 1,086 bars, more than 1,000 times the pressure at sea level. That's the equivalent of the weight of 50 jumbo jets pressing on your body. Human bones would crush instantly. Submarines collapse if not specially engineered. Electronics short out under the strain. Even materials designed for space exploration fail under Hadal pressures. And yet, life persists. In the 1950s, scientists first lowered cameras into trenches, expecting to find nothing but mud. Instead, they captured images of fish swimming in the depths. Since then, expeditions have revealed amphipods, shrimp-like creatures, thriving in the Hadal zone. Some grow to 10 times the size of their shallow water relatives, a phenomenon called abyssal gigantism. Others contain chemicals in their bodies that prevent their proteins and cell membranes from collapsing under pressure. Microbes thrive in sediment at the very bottom, metabolizing chemicals from the crust itself. Some even live within rocks miles beneath the seafloor, forming a deep biosphere that may represent most of Earth's microbial life. These discoveries prove that life adapts even in the harshest environments. One of the most extraordinary trench dwellers is the Hadal snailfish. Fragile and translucent, these fish live deeper than any other known vertebrate, nearly 8,000 meters below the surface. They appear delicate, with soft bones and bodies that would collapse in shallow water. But in the trenches, they are perfectly adapted, their cells reinforced by special proteins that counteract pressure. The snailfish is a reminder that evolution does not fear the abyss. Life goes where it can, even into the deepest cracks of the planet. Most trench life is microbial, invisible to the eye. Yet these microbes may hold clues to Earth's earliest life and to life elsewhere in the universe. Some thrive on methane or hydrogen from chemical reactions in the crust. Others metabolize heavy metals. Their biochemistry expands our definition of habitability, showing that sunlight is not required for survival. The Hadal zone may be Earth's best analogue for alien environments, like the subsurface oceans of Europa or Enceladus. If microbes thrive here, why not there? Fewer than a dozen people have ever reached the bottom of the Mariana Trench. In 1960, Jacques Piccard and Don Walsh descended in the bathyscaphe Trieste, spending 20 minutes at the bottom before returning. In 2012, filmmaker James Cameron made a solo dive, describing the seafloor as desolate, alien, and silent. Since then, robotic probes and submersibles have returned, capturing images of amphipods, snailfish, and microbial mats. But each dive explores only a tiny fraction of the trench. Most of its 1,500-mile length remains unseen. By comparison, we have mapped the entire moon in detail. We have not done the same for the trenches of our own planet. For all we've discovered, the trenches hold countless mysteries. Could larger creatures exist, unseen in the narrow trenches? Might ecosystems thrive in isolation, evolving separately for millions of years? Legends of giant sea serpents and megalodon sharks echo faintly here, fueled by the vastness of what we haven't seen. While science has found no evidence for such monsters, the trenches are large enough to hide secrets. The greatest mystery may not be creatures, but processes. Trenches recycle Earth's crust, pulling surface rocks deep into the mantle. Microbes caught in this process may be carried miles below the seafloor, surviving under unimaginable conditions. What role do they play in Earth's carbon cycle? How do they influence the atmosphere? We don't yet know. The Hadal zone resists exploration for simple reasons. It is expensive, dangerous, and technologically extreme. Few governments or organizations can fund such missions. As a result, we know more about the surface of Mars than about Earth's trenches. The deepest places on our planet remain almost completely uncharted, and perhaps that is fitting. The Hadal Zone is not meant to be conquered easily. It is Earth's reminder that mystery still exists. The trenches show us that life can survive in the harshest environments. But the ocean holds more than biology. It holds mysteries of sound, anomalies of geology, legends of monsters, and lost civilizations. In the next chapter, we leave the biology of the trenches and explore the mysteries, legends, and anomalies of the deep sea, from the Bloop to Atlantis, from shipwrecks to unexplained creatures that blur the line between fact and myth. For as long as humans have sailed, the ocean has been a source of both sustenance and fear. It is vast, featureless, and unknowable. When sailors vanished, when storms swallowed fleets, when strange creatures surfaced, imagination filled the void. From this came legends: the Kraken, the Leviathan, the mermaids of the deep, and the lost city of Atlantis. These were not simply stories. They were attempts to explain the unknown. And even today, when satellites circle the planet and science probes the deep, the ocean continues to produce mysteries we cannot fully explain. In 1997, hydrophones monitoring the Pacific picked up a sound. It was loud, so loud it could be heard across the ocean. Scientists called it the Bloop. At first, some speculated it might be biological, perhaps the call of some unknown leviathan larger than any whale. The mystery spread across the world. Was it a sea monster? A relic of myth, confirmed at last? Years later, analysis suggested the sound came from icequakes, massive cracking of Antarctic ice. But the fascination remained. The Bloop showed how quickly an unexplained anomaly can awaken old fears and stories. And it is not alone. The deep still produces unexplained sounds. Julia, upsweep, slow down. Some we can attribute to geological processes. Others remain mysterious. The ocean, it seems, still speaks in voices we do not understand. The most enduring myth of the sea is the Kraken, a giant squid or octopus said to drag ships to their doom. For centuries, sailors told of tentacles rising from the waves, of whirlpools formed by a creature's movement. Science eventually confirmed giant squid exist, but even now, they remain elusive. Few have been seen alive. Most of what we know comes from carcasses washed ashore or pulled from sperm whales' stomachs. If such massive creatures can exist almost unseen, what else might hide in the depths? Some point to the possibility of even larger squid or deep-living sharks, like the elusive megamouth shark discovered only in 1976. Each discovery suggests the deep sea may yet hold surprises. The most famous ocean legend is Atlantis, the lost city described by Plato. Whether intended as allegory or history, Atlantis has inspired centuries of speculation. While no evidence of such a city has been found, the ocean does hide sunken worlds. Off the coasts of India, Japan, and the Mediterranean, archaeologists have found ruins swallowed by rising seas. During the last ice age, sea levels were hundreds of feet lower. Vast areas of land, now underwater, may once have held human settlements. In that sense, Atlantis is real, not as a single city, but as a truth. The ocean hides our history. The ocean floor is also a graveyard of ships. From ancient triremes to modern battleships, tens of thousands of wrecks rest beneath the waves. Some are discovered, most are not. Among them are mysteries. The Mary Celeste, found abandoned with no crew. Countless vessels that vanished without trace in the so-called Bermuda Triangle. Science explains most disappearances as storms, human error, or piracy. Yet the mystery persists. The ocean hides evidence too well. A ship can vanish completely, consumed by depth and time. From time to time, explorers find structures that defy easy explanation. In 2011, divers discovered the Baltic Sea anomaly, a 200-foot wide formation resembling a disc or ruin, resting 300 feet beneath the surface. Some claimed it was a UFO, others a natural rock formation. The debate continues. Elsewhere, sonar scans reveal geometric shapes on the seafloor, sometimes dismissed as natural but sparking speculation. The ocean's opacity ensures that anomalies linger unresolved, fueling both science and imagination. The deep sea is the perfect breeding ground for legends. Its creatures are alien, its landscapes hidden, its sounds unexplained. Myths thrive in mystery, but again and again, science reveals that reality is stranger than fiction. The Kraken is real, though not quite as sailors imagined. Hydrothermal vents host ecosystems once thought impossible. Gigantic siphonophores stretch longer than blue whales. Each discovery reminds us that myths are not lies, but metaphors for truths we had not yet uncovered. Some might dismiss sea legends as superstition, but they serve a purpose. They remind us that the ocean is not conquered. They keep alive the sense of wonder and fear that drives exploration. And sometimes, myths lead to science. Stories of sea serpents may have guided researchers to giant oarfish. Tales of ghostly lights found explanations in bioluminescent plankton. The line between myth and discovery is thin. Both are attempts to make sense of the unknown. The ocean holds our imagination because it is, in itself, a story. It is a place of beginnings. Life emerged here billions of years ago. It is a place of endings, ships and civilizations swallowed without trace. It is both history and possibility, myth and fact, silence and mystery. And though we have charted its surface, its depths remain a narrative unfinished. The ocean's mysteries remind us how little we know, but they also point us forward. What secrets remain in the unexplored 95%? New creatures, lost cities, answers to questions about life itself. In the next and final chapter, we reflect on the future of ocean exploration, why it matters, what it means for humanity, and how the greatest mysteries may still lie ahead. The ocean is not just water. It is the engine of Earth, regulating climate, producing oxygen, absorbing carbon, shaping weather. It is also the cradle of life. Every living thing traces its origins to ancient seas. And yet, for all its importance, the ocean is also our greatest unknown. We speak confidently of Mars and distant exoplanets, but when it comes to the depths below, we live in ignorance. The ocean is a mirror, showing us not only what we know, but how much we do not. Exploring the ocean is not a luxury, it is a necessity. Climate stability. The ocean absorbs 90% of excess heat from global warming. Its circulation patterns shape storms, droughts, and rainfall. Oxygen supply. Half of every breath you take comes from marine phytoplankton. Food security. Billions rely on fish as primary protein. New frontiers of science. From microbes with strange metabolisms to chemicals with potential for medicine, the ocean is a reservoir of discovery. To leave the ocean unexplored is to leave our future in shadow. While mysteries linger in the depths, the surface ocean faces threats of our making. Overfishing has reduced populations of tuna, cod, and sharks by up to 90% in some regions. Pollution clogs the seas with plastics, creating floating garbage patches larger than countries. Climate change warms and acidifies the water, bleaching coral reefs and altering ecosystems. Deep-sea mining looms on the horizon, threatening fragile habitats we barely understand. We are changing the ocean before we have even discovered it. Despite challenges, technology is opening new doors. Autonomous underwater vehicles. AUVs map the seafloor with unprecedented detail. Remotely operated vehicles, ROVs, capture high-definition footage of creatures once thought mythical. Submersibles carry explorers to the deepest trenches. Satellite monitoring tracks currents, plankton blooms, and rising seas. Each innovation reveals more of the hidden ocean, but the pace is slow compared to the scale of what remains. Some envision a future where robotic swarms patrol the deep, cataloguing species and mapping ecosystems. Others dream of human colonies under the sea. Whether practical or not, these visions reflect a truth. The ocean is still a frontier. Beyond science and technology, the ocean teaches us philosophy. It teaches humility, that the world we think we know is mostly unknown. It teaches awe, that life adapts in forms stranger than imagination. It teaches urgency, that the ocean's balance sustains all life, and that balance is fragile. The deep sea is not just an environment. It is a lesson in perspective. In exploring the ocean, we also explore the universe. Hydrothermal vents teach us how life might survive on Europa or Enceladus. Bioluminescent creatures show us how life might adapt to eternal darkness. Microbial survival in extreme pressure expands our understanding of habitability. To study the deep is to prepare for discovery beyond Earth. The ocean is not just our past, it is a key to our future in the stars. We often say space is the final frontier, but the truth is, the ocean is our first frontier, still waiting. It holds the greatest share of Earth's mysteries. It guards secrets of evolution, climate, history, and perhaps even lost civilizations. It is as alien as any world we might visit, and it is here beneath our feet. To explore the ocean is to explore ourselves. How deep have we really explored the ocean's mysteries? Not very. We have mapped fragments, glimpsed shadows, heard whispers, but 95% remains uncharted, unseen, unknown. The ocean is not conquered. It is not tamed. It is vast, silent, and alive with secrets. And perhaps that is as it should be. For in its mystery lies wonder. In its depths lies humility. And in its survival lies our own. The ocean's story is unfinished. It waits for us, not just to explore, but to respect, to protect, and to learn. Until then, the question remains unanswered. What lies beneath?